Hello everybody, my name is Philipp Eichhammer and I will present my approach towards autonomous security monitoring in Internet of Things infrastructures. Before we begin with the presentation, a few details about me. I work as a research assistant at the University of Passau and started about a year ago, so I can be categorized as a beginner in research. This means I am currently finishing background research and starting on realizing my approach. My research interests include security in IoT infrastructures, dependable distributed systems, and fault-tolerant systems. Since the beginning of the Internet of Things as we know it today, applications utilizing this infrastructure concept have grown, and still keep on doing so. Chained to this development, the requirement of security within those infrastructures is rising. Besides standard security principles like encryption and authentication, monitoring is playing an important part in securing infrastructures as well, for example intrusion detection systems or honeypots. Despite being well established since several years or even decades, there is still room for improvement. We identified two significant limitations within the current situation. On the one hand, the use of multiple monitoring techniques is rarely combined, meaning we have low interaction between the mechanisms. There are some approaches for intrusion detection systems and honeypots to interact, but a majority of this potential is still not fully exploited. On the other hand, automated responses to anomalies are either non-existent or very limited, and in most situations require human intervention. As a result of these limitations, the quality of monitoring in terms of analysis results is potentially way below of what could be achieved. Additionally, the reaction time is way too slow due to the requirement of manual interactions. This is especially critical in IoT infrastructures, due to their complexity and high dynamic. So the goal of our approach is twofold, in that on the one hand we try to detect which mechanisms can collaborate to increase analysis performance and, on the other hand, having found possible collaborations, investigate upon their automation processes. Therefore, we identified three research questions. First, which cooperation of security monitoring mechanisms is most effective in increasing the quality of monitoring analysis results? Second, how can we realize an automation of each cooperation, thus reduce human intervention by automating responses to anomalies? And third, how to evaluate each automated cooperation strategy in real-world situations to ensure each implemented cooperation works as intended. To realize our approach, our current research has introduced a novel resilient middleware for IoT applications called Soria, featuring self-organizing mechanisms. The goal of our project is to simplify the development and runtime process of IoT applications while simultaneously increasing their resilience and security. This middleware will be used to embed and evaluate our approaches. Additionally, we analyzed a broad variety of resilience and security mechanisms, including monitoring approaches providing the possibility of collaboration, like intrusion detection systems and honeypots, where attack data from honeypots can be used to automatically generate signatures for intrusion detection systems. As a result, we introduced an extensive survey about resilience mechanisms in IoT infrastructures, providing a diverse collection of resilience mechanisms. Since I'm currently in the process of finishing the background work, the next planned steps will include the extent of analysis of possible collaborations between monitoring mechanisms. We already identified potential collaborations with intrusion detection systems and honeypots, but also with intrusion detection systems utilizing system monitoring information, like the infrastructure setup for an optimal placement of IDS agents. Afterwards, we want to investigate on custom automation strategies for the previously created collaborations, utilizing new techniques like machine learning. Further, we want to evaluate our strategies on real-world IoT use cases, provided with our Soria middleware, like smart urban parking management. Additionally, we plan to investigate on gathering real-world attack information utilizing our middleware and IoT honeypots for realistic evaluation scenarios.